So they have some specs for a car. And along with that, they have a GitHub repo for building a machine learning or, they basically, so they build a system so that you have your robocar with a Raspberry Pi, it'll take the pictures, then it will learn the throttle and the steering, and so they basically have a network that will eventually train and predict the throttle and the steering values. So, and the good thing is they got all this, the software and the hardware, kind of, at least for somebody starting off, they have nice instructions where you can just go grab some of those things and put it together and get off to training your own car. And so after checking there, I came home excited. I had a lot of these stuff lying around, and for a long time I was thinking of making a car. So I didn't exactly follow what they had for their hardware over on their website because I already had stuff lying. So I said, okay, let's put this together. If this works, then I can go and figure out, what I want to build the other stuff. So what I had was I had a Maker Faire. I think it's Maker Faire chassis.
Yeah.
I got maybe 6 months ago. I already had a bunch of Raspberry Pis. I got so I have a microcontroller. I had Arduino, but I was also looking to put some encoders for basically seeing how fast your wheels are rotating, so you could actually get some odometry. But that one is not done yet. But so I found this is ST microcontroller. It has an ARM processor. It's pretty cheap. It runs about 10 times faster than Arduino. Has 64 MB RAM and all that. So, and 20 plus digital. I mean the PWM and ADC pins. So it's got a whole lot more than what we really need. So.
And it has
Sure.
the VPUs. You're saying something about VPUs.
Sorry?
It has the
Oh, the Raspberry Pi has a VPU.
So you're basically using that MCU
So
as a
I'm
shield.
talking about the MCU, which is this small thing.
So walk us through
what
the
I
different-
use is,
Walk us through each of the different components.
so this Maker Faire chassis, if you can see, there are 4 motors, each driving the wheel. So it doesn't have, it's a sort of differential drive. So it just rotates by different wheels
Fully
rotating
independent.
faster rather than, it doesn't have the steering front wheels. So, and I had some old batteries that I was looking to replace my, one of the, these are sub-C batteries. So I 3D printed, some.
So take us from the wheels backwards. So you got the wheels, and then you have the motors.
So I got the wheels.
What's driving
I
the
got
motors?
So this is L298H bridge driving the motors.
So that's these guys right
so
here.
these guys over here. So I put 2 of those back to back. So just so that I can put them together on this. And
a dual H bridge, what it does is it translates 2 PWM signals into straight voltage from an amplifier.
so each one of these dual bridge has 2 channels. It can either drive one servo. If you know, servo motors are where you can have an angle and it'll stay at an angle. And the DC motors, or you can drive 2 DC motors. So in this case, these are all DC motors. So I'm using 2 plus 4 DC motors to drive this. And if you had like a steering wheel type, you could, most of the RC cars these days have a steering servo motor for driving the steering in the front, and then your DC motor to drive the rear wheels or whatever, the driving wheels. But usually the cheaper cars will usually have like a DC motor for the front so it just doesn't have a control over the angle. So in this, so these are basically
The drivers.
I mean they drive the current because your Arduino or Raspberry Pi won't supply that much current. And if you try to do that, I mean, their pins don't drive that big current. So you need a H bridge or something like this to drive your motors because your motors tend to draw a lot of current. So these ones actually can have like a 2 ampere current. They can, so which is pretty good for if you wanted to run really strong motors. These ones are pretty flimsy motors, but it's just an experiment, so I wanted to get that done. So now I have this MCU that basically so what you need for these these H bridge is you need enable signals to so for both direction, whether it's moving forward or backward, and then it needs a PWM signal, which basically, I mean, I think everybody understands PWM, right? It just changed the
Not everyone will understand PWM.
duty cycle. So what you have is you usually have a digital signal is just high, low, and with the PWM, what you do is you basically change the width of how long it stays high. So if you basically say, typically it would be 50% high, 50% low, but you can change it. You can say, it goes high and then after, say, a millisecond, it will go down and stay down for 5 milliseconds. So that will give it short pulse. But then you can control the width of that to actually
So if it were high,
drive your motors faster or slower.
so if it's high for 1 millisecond and then low for 5 milliseconds, that would be a 16% PWM.
Yeah, 1/6. So
Yeah.
And
that's
does
16.
PWM stand for pulse wave modulation?
Yeah.
Yes. So
Pulse
it stands for
width
pulse
modulation.
pulse width modulation.
Right.
Yeah.
So it's just doing that fast enough so that for the motors, they would just see a kind of drop in the voltage. So they're not running as fast as when you have it at the full pulse. And so that's the PWM signal.
Just one thing for steering. So pulse width modulation too. If it's very low, would mean, for example, turn very far left. If it's very high, it'd be turn very far right. So you can use pulse width modulation to not just signal for a motor to spin, but an actual precise location. So for steering servos, you set a PWM right in the middle, and that means drive forward or to the left or to the right.
Right.
And I forget the granularity. But
Well, I mean,
How will this
so
thing turn? How will this thing turn?
so this will turn by basically making the one side motors go faster, the other one slower. So if you
that's what he meant by differential drive.
Yeah, that's sort of the differential. So if you kind
That's
of
very
reverse
clever.
wheel the other one, so
Yeah.
turn around,
That's very clever.
and that way it can actually do sharp turns compared
Yeah,
to
Absolutely.
the other your
That's
steering
pretty
wheel
cool.
ones, because
Or in-place
their
turns.
angle might be
Sorry?
limited.
It can do in place turns. It can do rotation.
Yeah, in place
That's
rotation.
different. That's because it's got like four.
But
Four
it
independent
needs
motors.
sort of, that depends on the slipping.
It's
of the
basically a
wheels.
small Tesla, right? I mean,
Yeah.
just kidding.
So for sensors, we just have two
So-
cameras.
So go back. So yeah, keep going.
Okay. So we talked about this one. So this actually, so one thing I wanted to mention is it can either drive 2 DC motors, each one of these, or you can drive a servo motor. Servo motor typically needs
Also amperage.
Yeah, it's kind of it takes both the channels, so it needs usually 4 inputs for a servo motor.
Thanks. So the key thing he's mentioning there again is you could drive a servo right off of this because it's generating PWM, and servos take PWM. But if you did that, then this little chip would pull all the amperage through it, and that little MCU would get super hot for about
Well,
half a
it's-
second, and then it would be
well,
very
even
cold after that because it would be dead.
Usually what they do is they limit the current on these
Yeah.
MCUs. That goes like 30 milliamp or 40 milliamp, and your motors will not budge. And the other thing is,
Or it'll pull.
if you did the other way, I mean, when the motors stop or you actually rotate them, they're gonna generate a current, so that will actually
An
fry
inverse
the
current,
MCU.
yeah.
So you kind of, that's where the H bridge is.
And that's a 298
less-
H bridge? I didn't hear
Yeah.
you said 298. Okay.
290. Yeah. So So the MCU kind of, right now I programmed it to say, okay, what if I get this throttle and this angle, what am I going to do, right? And then I put this. If you
And did you write that
there's an
program, or did you
analog-
download that program?
I wrote that.
So just like in Python or in C or?
That's using the Arduino IDE. That's C.
Okay, got it.
I mean C++ essentially. But yeah, but the Arduino IDE makes it pretty reasonably simple if you know C, C++ to make that. And what the reason I put that is because I also wanted. I put the distance sensor. This is a infrared sharp distance sensor. So I mean, rather than ultrasound, it kind of has lower latency with that. So just wanted to.
But it also has lower range, right? The IR only has a pretty short range.
Yeah, it's about 3 feet.
Oh, that's actually pretty good.
Yeah, I think 80 centimeters. Yeah.
That's,
So 80 to even 150 they can have.
okay.
Some of them have better. So I think the other one, usually they put the lenses and those things, so they can actually
Cool.
have a much better range on this one. And so the reason I put that is because I wanted it to stop if it saw any obstruction rather than,
Destroy itself.
yeah, destroy
Having a
itself.
little bit of experience of watching your robot run into a tree for an extended period of time.
So,
So for the wheels, say you're driving all simultaneously. Let's say, so you, how do you think one goes on? You don't. You
yeah,
don't
I mean,
really care,
so that's
for
the
this.
stuff that the MCU is doing is essentially, if I get a throttle and an angle. So I mean, right now it's just a simple calculation. Okay, take certain part of throttle and angle, and on one side you add it, the other side you subtract it, and it'll turn around.
Yeah, but
And
for
that-
the forward motion, you both will get the
For
signal. at
forward
the same
motion,
time.
you just give it all of them the same, right? And typically, what tends to happen is, I mean, usually this one runs pretty okay, but all your wheels might have different friction or whatever, and then you might end
Or the
up
motors aren't
going
calibrated.
one on this side or the other one, so you have to kind of calibrate the ranges for those ones to. make
And then
sure.
driving all that, you have the Raspberry Pi. So that's connected by USB
Right.
to the Raspberry Pi.
So-
So what's running on there?
So the MCU controls the rest of it, but MCU needs the throttle and the angle, and those angles are actually coming from the Raspberry Pi. And what we have here is, I have the Raspberry Pi, and I have a Raspberry Pi cam. It's actually pretty capable, 5 megapixels, but we
Overwhelms the poor Raspberry
yeah,
Pi,
I mean,
right?
you can actually do high def video connected, and it'll do that. But and it actually more resolution than that. So the whole idea is it'll take pictures and take the frames, and basically, if it has a trained network, then it'll be able to generate the throttle and the angle, the steering output for this car.
Don't we need 3 cameras like we saw the last?
So yeah, I wanted to finish this and then talk about where we want to go with it.
Right.
But you're spot on, right? Anything else you want to add about this? Any other
So-
key customizations or things that you added?
I think those are pretty much it, So I think what I had to do was, so the donkey came, I mean, they had a little different design. So I needed to, I was trying to figure out if I should directly drive the MCU or, use the GPIO pins to connect and feed the same input, but, I just chose USB, and then you need to basically write some portion for the donkey to understand, okay, pass these over to the MCU, so my MCU can.
So you made like a handler from Donkey instead of going right out of GPIO to go to the MCU.
Right.
Okay.
Is white block a battery? Or what's the...
Yes, white one is a battery.
So that's probably like a cell phone charger battery,
Yeah.
right? Because that's 5 volt and just like 4,800 milliamp hours or 10,000 milliamp hours
16,000.
or 16,000.
So how long can you run it?
I haven't really tested it, but it shows like 20% down or 30% if I do it the whole day. So I think
So one of the reasons to use the battery